Hi, welcome. My name is Boel Ekberg. I'm the application specialist of the Megger factory in Sweden. Today I'm going to do a measurement with EGIL200, and I'm going to measure on a medium voltage circuit breaker, and I'm going to use B10E to supply the voltage. I'm going to do timing and a motion measurement and also measure the coil current. I start with the connections. I have a connection diagram to follow which shows all the details. This document is in the delivery of EGIL200. And I start following the instruction. I connect the plus and minus to supply to the circuit breaker analyzer. And I connect the plus and the minus on the analyzer. I continue with the rest of the connections for the control. The plus and the minus here creates the pulse to operate the circuit breaker. I connect close at the analyzer and close at the circuit breaker. I connect open at the analyzer and open at the circuit breaker. To meet the minus from the analyzer to the circuit breaker coil. I also need to supply the motor. The motor which charges the spring of the operating mechanism of the circuit breaker. The plus and the minus from motor the plus and the minus on the circuit breaker. I continue with the timing cables. It's a special medium voltage breaker cable, so it is a common cable set for all three phases, A, B, and C. The cables are color-coded, and I have a red for phase A, and I use the clamps in the system. And I connect on both sides of the pole. A, B, and C. I also need to connect my auxiliary contacts. I'm going to measure one A and one B contact. Again, the cables are color-coded. The first, the A, on the instrument, and A contact on the circuit breaker. The aux B on the instrument, and the B contact on the circuit breaker. Let's go over to the mounting of the transducer. To do this, I have prepared the different parts from the ready-to-use mounting kit, the clamp, the arm, the white holder, and the transducer. I need to mount the details together. Steady. I go over to mounting the transducer in the white holder. And the flex coupler at the axis. This must have a distance in between here. And the cable is connected on the other side. And now we're ready to mount it on the circuit breaker. I have connected a part from a rotary kit on a rotating point in the mechanism. This rotating point reflects the motion of a pole. I have prepared the angle so I can easily connect the transducer. I need to connect it steady with a C-clamp and adjust the angle so it's aligned and properly and steady. And I have to connect and adjust the flex coupler. The transducer is connected and I need to connect the cable. So I need an extension cable. I use a normal analog cable. At the instrument and extend the transducer cable at the transducer. I need to check that I have my link connected, so I will have continuous supply from the coil. To prepare the circuit breaker, I need to charge the spring. So I need to run the motor with B10E. I put B10E to motor, and I'm going to run the motor. It's going to be a little noise. And I change over to coil. Now I need to do my setups in the GUI, in the instrument. The connections are made and I just have to check my settings in my instrument. If I continue on a circuit breaker of the same kind as last time, everything is prepared and I can just turn the knob and measure. I do a close operation. Here is the result from the measurement. If another circuit breaker has been tested, you might have to change a few settings. I will show another example. Here I've measured a bigger object last time, so I have to do a few changes. I go to New Test, Quick Start, under Common Task, and I go to Metadata to give the circuit breaker a name. And then apply the changes. I go to Test under Metadata to adjust my object. I have a smaller breaker, a common mechanism, and I only have one break per phase. I want to measure timing, and I want to do a motion measurement. So I have contact motion, analog, and I want to have 100 millimeter as a stroke. I also want to have auxiliary contacts, one of each kind, A and B contact. And I want to measure coil current internally. And I see that the circuit breaker is open and I want to do a close operation. And I continue to the connections. Here I can see indicated which channels are in use. And I can also see the details. The control, the auxiliary contact A, and as example also the MR channel. And now I'm ready to turn my knob. Here I have my result as a graph. I have my coil current at the bottom, a very low current. I have also my timing traces, red, yellow and blue. And I have my auxiliary contacts in green. And I also have my motion measurement in green. I want to see my results as a list under parameters. And I can print out either to my internal printer or go to report, where I can select what I want to print out to my PDF. To continue, you can change operation type to open, and the menu will be extended with a new operation. Below to the right, you can see the circuit breaker indicates closed position. If you later want to do a new close operation, you select the operation in your menu. This was what I wanted to show you today. Thank you for your attention and good luck with your measurements.